Properties of functions. We make extensive use of several key properties that functions may possess. In this section, we start by discussing the main properties that we use, which are monotonicity. The graph of a function always goes up or always goes down. Continuity. There are no breaks in the graph of the function. Concavity and convexity. The function consistently curves upward or downward. And homogeneity. The function scales up or down consistently. After reviewing these properties, we list three properties of the logarithmic function that we use repeatedly. Monotonicity. A monotonic function is one that is either always increasing or always decreasing. For example, the identity function f of x equals x is monotonically increasing. That is, as x increases, so does the value of the function f of x. Some functions are monotonic only under certain conditions. For example, the function f of x equals 1 over x is monotonically decreasing when x is positive. The function f of x equals x squared isn't monotonic. It is decreasing when x is negative and increasing when x is positive. Continuity. A function exhibits the property of continuity if a graph of the function has no jumps or breaks. A function can be continuous at a point if there are no jumps or breaks very near the point. If the function is continuous at all points, we say that the function is continuous. A sufficient condition for a function to be continuous at a point A is the limit as x approaches A of f of x equals f of A, which indicates that the limit of the function f of x as x approaches A is f of A to the power 2, which reads, that is a subscript 2, which reads, if an infinite sequence tends toward some particular value as we progress through that sequence, that value is the limit of the sequence. For example, in the sequence open curly bracket 1, comma 1/2, comma 1/3, comma 1/4, ellipsis, close curly bracket, the nth element in the sequence equals 1 over n, where n is a positive whole number. As n gets larger, the value of 1 over n tends to 0. So the limit of the sequence is 0, even though 0 is not an element of the sequence. Concavity and convexity. Economists make extensive use of the properties of concavity and convexity. We say that the function f is concave over a region capital A if the graph of the function f of x never goes below the line drawn between any pair of points capital A. For example, in the panel A of figure A.1, we evaluate a function f with domain capital X. Within this domain, we choose a subset capital A and we evaluate f at 2 points x and x prime within this subset capital A. This procedure gives us 2 points in the range of f of x, and f of x prime. The line connecting the points, open parentheses x, comma, f of x, close parentheses, and open parentheses x prime, comma, f of x prime, close parentheses, is below f of x for all x between x and x prime. This never below the line test reflects the intuition of concavity for functions of a single variable, but for functions of multiple variables and for testing the concavity of a function that we cannot easily draw, we have a better test. To illustrate this approach, we examine the concavity of a function of a pair of variables, open parentheses, x, comma, y, close parentheses, that maps f colon capital X times capital Y yields capital Z. Again, let capital A be a subset of the domain of f, comma, capital X times capital Y, and choose 2 points from the domain, open parentheses, x, comma, y, close parentheses, and open parentheses, x prime, comma, y prime, close parentheses. The function f is concave over capital A if for any value of theta such that 0 is less than theta and theta is less than 1, and for any pair, open parentheses, x, comma, y, close parentheses, and x, and open parentheses, x prime, comma, y prime, close parentheses, in capital A. F of theta times x plus open bracket 1 minus theta close bracket times x prime, comma, theta times y plus open bracket 1 minus theta close bracket times y prime close parentheses is greater than or equal to theta times f of x, comma, y, close parentheses, plus open bracket 1 minus theta close bracket times f of x prime and y prime, close parentheses, no close parentheses needed. That's equation A dot 1